Hello everyone and welcome to mojo4industry development debate on latest trends in laser cutting and metal handling sponsored by Laser Cutting Systems India Private Limited. Laser cutting is a widely used manufacturing process, whether it is aerospace, automotive, electronics, semiconductor, or even medical equipment industry. Laser cutting offers a huge range of benefits and applications. The rise in automation in manufacturing industries, owing to the demand for high quality products all around the world, is driving the market for laser cutting machines. Today we are going to discuss on why state-of-the-art laser cutting and metal handling solutions are important in today's manufacturing. And I'm glad to welcome our distinguished panelists. We have with us today Mr. Utkarsh Landekar, Head Laser Business and Exports, Laser Cutting Systems India Private Limited. Mr. Ravichandran Duraiswamy, Senior Manager Product Management, Laser Cutting Systems India Private Limited. We will also be joined by Mr. Uday Mukherjee, Director Sales and Marketing, and Mr. Prashant Chaturvedi, General Manager Marketing, Laser Cutting Systems India Private Limited. To start with, I will invite Mr. Uday Mukherjee to give a brief introduction of today's topic.
Thank you, Mr. Roy. Today's session, as Mr. Roy has briefed, that it is focused on laser cutting, and we are also going to discuss about the latest trends in material handling also. Laser Cutting Systems is basically a German company, family-owned, technology-focused company from Germany. So this is almost 123 years old company, originated from Frankfurt, Germany. Primarily, we are manufacturing these products in 5 regions. The mother area is the Germany, then we have USA, then we have in China and India and Brazil. History is that Messer was actually the originator of CO2 laser cutting in the globe. We started our laser cutting activities in 1970s, which a lot of our clients, customer or people do not know. But we were there right from 1970. But in between, we focused more in our plasma and gas cutting machines. While focusing on plasma and gas cutting machines, we knew that we have developed lots of expertise as far as the R&D is concerned for going into fiber laser. So in 1997, we restarted our laser activities in the form of laser mat, so which are gantry-based machines. And then in 1998, we went into pallet changer type of machine with CO2. And then 2007, we started our new generation fiber blade machines. And these were basically manufactured in China as well as Germany. And then in 2017, actually, we relaunched these machines in India, started manufacturing in Coimbatore. So whatever machines you see in India is 100% manufactured in Coimbatore, India, as well as these machines are exported from India to Middle East, Canada, and now USA also. So I would like to only mention here that Messer cutting laser machines are basically European machines made in India. So you get the best of the machines, European quality machines at Indian rupees.
So now we will turn the time over to our opening speaker, Mr. Utkarsh Landekar. Presently, he is handling Messer CNC cutting machines for last 16 years and managing laser sales, service and application pan-India and Middle East region. Now, Mr. Utkarsh will highlight the top laser cutting trends that will drive the future of laser processing. Welcome, Mr. Utkarsh.
Thank you, sir. Now, the experience what we have gained for more than a century that makes us create one bubble diagram, which is useful for all the engineers who are going to decide which process is suitable for what tolerances and how the thickness can influence the process to be used and how exactly we have to take it further from here. So when we look at very short tolerances, or when we are looking into 0.1, 0.2, up to let's say plus minus 0.5, then you are into laser zone, wherein from 0.5 millimeter until 25 millimeter is a viable process as on today in 2021. Of course, this bubble is likely to expand and become much bigger as the laser powers are going up, and we will be discussing on that. Plasma, which has been dominating 1 mm to 150 millimeter, and the tolerances here are 0.5 millimeter to plus minus 1.5 2 millimeter also, depending on thickness. And of course, oxyfuel is the age-old, century-old process which has been invented by a messer that forms 6 mm to 3 mm area of operation. Now, when we look at a same job to be cut in overlapping areas, let's say 10 mm or 12 mm can be processed with oxyfuel, plasma, and laser. And when we look at all the three processes doing the same job, the productivity will be one of the criteria. In certain thicknesses, let's say for example 12 mm, the job can be done in 43 seconds, laser will take 57 seconds, typically a 4 kilowatt laser. And if you look at about oxyfuel, it will take 2 minutes 46 seconds. But as the thickness keeps on going up, laser and plasma starts losing out, and only oxyfuel remains in the race for mild steel cutting. Now, as we are looking into the industry where they need to select a process, so there would be some criteria wherein the entire industry across the country treats us as a consultant. So when we are in a consultating mode, we have more than 1,200 customers, wherein these customers would always discuss with us what is the right capital cost, whether it is high or low, whether cost of maintenance, power cost, gases cost, which are the gases to be used, how they are to be handled, what are the curve clauses. So we also do the yield analysis and the time study for our clients. Then how to train your manpower, upgrade their skills to get maximum out of a machine, which are the methods to maximize the yield, whether you need to change the process or you need to use a good software or good mechanisms to get maximum material yield, and what are the day-to-day consumables that are required. So when we look at the cost of cutting, which is the buzzword today, we always have our customers coming to us and taking our word as a guideline for their decision making. Let's say typically when we are going into the process selection mode, we have 5 mm, 10, 20 and 50 mm of mild steel forming a majority of the plate cutting happening in the industry. And how do we select a process? One will be based on the cost. Secondly, it will be based on the capability. And third is what is the production you are going to get per hour. So one of the case studies is that there is a exhaust fan or a FD fan manufacturer who manufactures the impellers and casings. So he has to use a 1500 by 6300 plate which is available in the market. And then he has to make a choice which process to use. So we have shown you the diagram, laser versus plasma process. Apparently it seems that plasma is burning out more material, but sometimes burning out more material can also give you good surface finish, and it gives a yield which is not very bad. You can still manage with the yield. And laser will definitely give you more parts from the same plate, and it will be giving less heat input, and there are no post-cut operations. But the range is limited, as I have shown you in the bubble diagram, 0.5 to 25, which is reliable. Next criteria, when you select a process between oxyfuel, plasma and laser, the hole diameter comes as a stumbling block, which prevents you from choosing one process or other process. So if you take oxyfuel, the reliable holes are having diameter of twice that of the thickness. In plasma, between 6 mm to 25 mm, you can still get 1:1 ratio. Otherwise, the ratio still remains like oxyfuel, twice the diameter of the thickness. That is 10 mm plate, you can have 20 mm holes. In laser, between 0.5 millimeter to 25 millimeter, you can still have the ratio of the holes 0.7 times of the thickness. Now, with this background, the lasers has started growing by leaps and bounds. So, if you look at any growth rate, it is surpassing any industries. The growth rate is at 69% of the overall laser cutting market, and out of which the high power laser. When we say high power laser, we call the laser which are more than 3 kilowatts as high power laser. However, when we say higher laser power comes with a higher responsibility. That is, you need to handle the laser properly. You have to handle the laser in a safe way, and you know how to handle the laser. So that's how we say higher power laser comes with a higher responsibility. Let's say if you have to cut 1 meter by 1 meter 10 mm mild steel, and 1 meter by 1 meter by cutting with nitrogen on 2 millimeter stainless steel. So you also have to look at the power taken to cut the material, and what is the economics, and in how much time you are going to cut. So higher power gives you some benefit. There are some disadvantages, but definitely the economics always surpass many of the disadvantages. So you need to use the correct type of gas. It definitely influences the cost of consumable. It influences the cost of cutting, then the quality of cutting, and you need to draw the correct amount of gas through correct near the cylinders. Then this is a very interesting example what we did for a defense equipment manufacturer in the Middle East. So this equipment manufacturer, he was making armored vehicles, and he was producing the trucks which are meant for defense application. In that, he was using laser process of 4 kilowatt, and he was cutting the same in 84 seconds. This application was for mounting alternators onto a truck side frame. So here there were a lot of holes, wherein the hole-to-hole center distance was crucial, and from outer periphery there was just a smooth surface required. So with this case study, we did the same job with a laser plasma combination, wherein only laser, it was taking 84 seconds, and the laser machine was using 4 kilowatt of laser. But what we did, we cut the holes with 4 kilowatt laser, and the outer periphery with a plasma of 200 amps in 77 seconds. If we upgrade the plasma to a higher level, maybe we can still do the job in lesser time. So the accuracy is ensured by laser, and the maximum distance is covered by the plasma. So this is the latest trend what we have been processing, and we already have supplied equipment with such combinations, and customers are very happy to use this techno-commercially viable process. So Mr. Ravi, you can start with the IoT and automation and material handling solutions.
Thank you, Landekar. There was a nice presentation by Landekar on the laser cutting process, and what Mr. is offering for the laser cutting industry. And what I'm going to talk about is, leaving around the laser machine, we have got a lot of other peripheral activities happening around the machine to have the industry running. So the main thing is automation and IoT of machines, right? So we have softwares which can give full monitoring to the management across the globe. You need not be in the factory at all. These are all based on internet, and it can be monitored from anywhere. So we need not have a separate team of people going around doing the production process study. So what it means is, it is fully automized cutting can be done with our system. And we have got two. This package is called a OmniFab package, wherein we have got two types of two segments. One is on the ERP demand and cutting the material and the data going back to the ERP, so that the customer has the full cycle of data of production happening on the shop floor. And another one is the system is the machine inside, which gives you the performance of the machine. So how well the machine is utilized, how well the operator uses the machine, and how much time it takes for the setting up of the machine, and if there is any breakdown, how much time the machine is down for a particular period of time. That is automatically given in terms of data, in terms of pictorial representation to the management directly. It is, and to multiple users can have it, and they can monitor the performance of the machine. So right now the industry is more into these activities which will aid the cutting process, production process, which will aid the cutting and production process, so that what happens is your production process goes on uninterrupted, and planning can be in a better way. And now this is on the machine performance and on the production side. And there is another thing, what we call as material handling system, which actually is a huge chunk of contributing factor to what you can say, machine waiting time, waiting for the material to be loaded. So machine is actually, you can remove the ideal time for loading, unloading, and setting in time by these material handling systems. So what happens is, the benefits of the system is unwanted, unskilled labor is reduced to a greater extent. And when you use a storage system, what happens is your 60% of your flow storage system, more than 60% of your flow storage system gets reduced. And you have a systematic way of managing your inventory. So your inventory cost is also coming down, and unwanted labor cost is also coming down. More than the machines, the peripherals like material handling and IoT and machine monitoring systems are more important in an industry. Yes, people loading it onto the machine and unloading the cut parts onto another trolley or a storage system. That is one part of the material handling system. The other part is the raw material storage itself. So separately, we can store. We can have a vertical storage system where the storage can be well organized, and that can be integrated with the ERP system. So the planning person knows how much material is exactly available at which location. So to that extent, the inventory can be maintained. To this, if you have a machine, so what you can see now on the screen is a machine. Machine is not visible because it's on the other side. Machine is coupled with a storage system and the loading and unloading equipment. So what happens is, the advantage of this is one person can manage the whole process. They can, first the material is loaded onto the storage system and logged in onto the inventory system, wherein the material quantity and material type is specified in which pallet it is there, and from the machine the material is pulled out. So the command comes from the machine to take one particular material, and the material is taken out, the pallet goes out, and the loading system picks each one plate from that pallet and loads it onto the machine. And the moment the material is cut, the unloader picks the material like a fork and puts it onto the other side of the machine. These are the major parts. Like one is the loader, one is the unloader, and one is the tower storage system.
Thank you so much, Mr. Ravichandran, for sharing in-depth information about the latest trends in material handling. For your information, Mr. Ravichandran Duraiswamy is the Senior Manager Product Management at Messer Cutting Systems India Private Limited. It was great hearing from him. So to start with, Mr. Utkarsh, why adopting state-of-the-art laser cutting solutions are becoming essential today?
Today laser cutting machine is replacing shear drilling machines, turret punch press, plasma machines, and to certain extent oxyfuel machines. So this is getting more and more, like one process replacing several conventional processes. So that is making it more prominently usable in the industry. So this would be the specific answer I would like to give. And the beam that is used to process the material is so thin that even the smallest of holes can be managed on thicker plates. So that gives a better advantage for the process.
Mr. Ravichandran, you were talking about the material handling solutions and how we are actually, adopting advanced solutions day by day, and it's becoming almost integral for the manufacturing processes. So, why is it essential to have advanced material handling solutions in the manufacturing process?
Nowadays, the production happens at round the clock, 24/7, and what happens is in that you have to feed your machine without any interruption. So if it is manually handled, then there is a lot of management work to be done. So if you want to utilize your machine capacity to the fullest, you should definitely have to automate your whole process. And the whole process means not just the machine, the handling systems and the monitoring systems which go along with the production process also. So if we actually automate that, definitely you can be rest assured that your production goes on uninterrupted throughout the planned time.
I would just like to take his question forward, very rightly replied by Mr. Ravi. Just imagine that when we are talking of oxyfuel process, plasma process, and laser process, there are two speeds that we generally talk of. One, we talk of the cutting speed. Now, this cutting speed is a process limitation. It's defined. You just cannot just keep increasing it. Then we talk of the positioning speeds. That means that before the cut process or between the parts, how fast your machine works. So these two processes, everybody is increasing. But at the same time, if we are, having a fastest machine, but at the same time, we are not handling the material rightly, and we are taking, there is a lot of idle time between loading and unloading of your components, either the raw material or your finished components. Actually, then a very fast machine will make no sense. So generally people tell that I have the fastest machine, we have very high cutting speed, and it's all fine. During the cutting process, you saved a lot of time. But if you wasted a lot of time in handling the inward material and the finished part, actually you just invested more. So if we are really looking forward for a productivity solution, apart from the fast and quick, accurate machines, we also need the solutions that Mr. Ravichandran has elaborately defined, where the loading unloading part, the part of the machine process is totally taken care, and that time is reduced.
Mr. Prashant, just kind of extension what Mr. Utkarsh was talking about. There is a kind of shortage for industrial use of oxygens, and industry was struggling. And you actually take care of the oxyfuel businesses for this measure in India. So how did you manage this kind of thing, and how could you actually meet your client's requirement at that point of time?
I will answer the question partially. See, when there were shortages of the oxygen and nitrogen, we modified our controller softwares to suit the air cutting, even in the high definition plasma and laser modes. And many of the oxyfuel cutting equipments which were there in the equipment which are, let's say, for gas cutting or for normal manual cutting where oxygen was required, we supported the industry with air plasma systems. And as I was telling that there were more than 1,000 installations. So in all the 1,000 installations, everybody was facing the oxygen or nitrogen problem. So we had to recalibrate, then we had to do the software programming, and we supported the industries very well. Our engineers were traveling passes to go to the customers to support their machines, because those machines were also producing some oxygen making plants and other things. So this is how we supported the industry by the use of air to the maximum limit inside that, and we converted that. And for heating application, we had some of the oxyfuel equipment which was running on normal atmospheric air, and the heating could continue with that. This is all the support by us to the industry.
Yeah, he fairly answered that. And many of the customers shifted from the oxy-fuel process to the plasma process, the manual plasma as well, because you know that we even have a complete manual plasma range as well. And when oxygen was not available, we changed the parts for them, you know, the consumable parts, and many of the machines were running on air. And subsequently, as oxygen started getting available, we moved on to oxygen as well. But we could really sail through that time very well. Yeah, thank you. But we could really sail through that time very well. Yeah, thank you.
Mr. Uday, just one question to you as well. As there's a kind of transition happening in the manufacturing industry with the advent of Industry 4.0, thanks to the high grade of internet technologies and mobile technologies. So how do you see that it's going to affect the business of laser cutting as well?
So it's a matter of adopting the technology with Industry 4.0, and I think during Ravi's presentation, he has also mentioned that how we are geared up and equipped with a software called OmniFab. So it's in the similar lines. So with those type of arrangement, we can always address the concern of industries. So this not only gives the insight of the machine, but it also schedules the production and also speaks about the productivity and also speaks about the reasons of the downtime, etc. So I would say it is complementing already, and we are geared up with our various software technologies. And for your information, for information of the participants also, Messer has its own Messer Soft company. It's a part of Messer Cutting Systems. So it's called Messer Soft, who are 100% dedicated to the software for cutting technology. So we are fully geared up. We have already implemented something.
Great to hear that. So just one last question of this panel discussion. Many manufacturers or the product engineers are available in this participants list today. So if I have to ask Mr. Utkarsh as well as Mr. Ravichandran, that what are the factors that affect the selection of laser cutting machines as well as material handling solutions? Could you just summarize?
So when we look at a process selection, as I had given the 2-3 diagrams, one was a bubble diagram, which was very clearly showing the tolerance versus the thickness. Second criteria is the hole diameters for the material compared to the thickness, and then other than that, what is the productivity and what are the after cutting operations, that is post cutting operations. This will give the selection factor. And Mr. Ravi can answer further on the material handling, how to store the material and take the material for fast production.
Yes, that is selection of material handling or storage depends on the volume of production they have, repeated production of components. That will define the way they want to store the material, or that is, we can have storages to a couple of, that is, we can have one storage or two storage, or split up with machines, how to couple machines with storage systems. All that can be defined based on the production capacity and the requirement of the customer.
Before concluding today's session, we would like to thank our distinguished panelists, Mr. Uday Mukherjee, Mr. Utkarsh Landekar, Mr. Ravichandran, and Mr. Prashant Chaturvedi. Thank you, delegates, for attending. We hope you have enjoyed this session thoroughly. It is understood that as automation, Industry 4.0, and the Internet of Things are creating waves in the manufacturing sector, advancements in laser cutting technology will surely be towards being intelligent. With this, we conclude today's mojo4industry development debate on latest trends in laser cutting and material handling, sponsored by Messer Cutting Systems India Private Limited.
Please don't forget to subscribe our YouTube channel and press the bell icon.